Problem 37 is part of the in-class work. Taking a look at this guy here with his yo-yo. So it gives us an equation, and that equation is based off of how far away the yo-yo is from his hand. And it says when y equals 0 is when the yo-yo is in his hand, and then we have y is negative when it's below his hand. So when we take a look at the first problem, part A, we want to solve that quadratic to find the time the yo-yo was in his hand. So I'm going to take this equation, set it equal to 0, so I'm going to put 0 in for y. And there are several ways I could solve this now. I could do the quadratic formula, or I could do factoring. I'm going to factor this one because as I look at it, there's a greatest common factor of x that I can take out of both. So I factor this into x times 2x minus 4.8 equals 0. I can now do zero product property. So my two factors are x and 2x minus 4.8. So x equals 0 from this factor. And the other one is 2x minus 4.8 equals 0. Moving the 4.8 and adding that to both sides, I get 2x equals a positive 4.8. And then dividing by 2, I get x to equal 2.4. So at 0 seconds and at 2.4 seconds, the yo-yo is in his hand. So it took 2.4 seconds. For problem B, we want to know how long it takes for it to turn around. So if we think of the yo-yo, it's going from his hand, it's going down, and then it's coming back up. Well, if I think of this more as a graph, it's going to come down, it's going to go back up like this. So we want to know when is it turning right here. If this is at 0 and this right here is at 2.4, our line of symmetry would be the spot where it would turn back up, which is going to be halfway between 0 and 2.4. So halfway between those will be an x value of 1.2 seconds. So then problem 3 is how long is the string? So essentially what we're trying to figure out is what is the length, or how low is it at 1.2 seconds? To do that, I'm going to take the original equation and I'm going to substitute in 1.2 for x. So 2 times 1.2 squared, I need to square this first, and then multiply it by 2, and I get 2.88, minus, I multiply these two together, I get 5.76, and when I subtract those, I get a negative 2.88. That is the distance in feet that the yo-yo's string is going to be. So now problem D, I want to go through and make a graph of this. I want to get some important points, such as when the yo-yo is in his hand and when it changes direction. So this is now the y value of my vertex. The x value of the vertex was 1.2. So this is a parabola. So if I go through and make my graph, that is at 0, 0, it's in his hand. Also at 2.40, it's in his hand. So I've taken care of that part. The line of symmetry we said was at 1.2. And my vertex is down here. That's the lowest point. That was 1.2, negative 2.88. And there's your graph. Hope that helps.